Hello guys, welcome on Tesla Adventures. In this video, I am bringing the level 2 problems which are especially for the preparation of JEE Advance and Olympiad stage 1. And in these problems, you would be finding out some questions from the biggest books of physics for JEE preparation. I would not name the books, but you would be relating those names by seeing the questions. Okay, so first of all, you can see that in this question there is a parachute jumper which jumps from a height of 100 meter, and after falling freely for some time, he opened the parachute. And after opening the parachute, his acceleration was a is equal to minus 2v, and he has to reach the ground with zero velocity. So let us suppose that at this instant his velocity is u, and u would be under root 2gh, because he has fallen freely, free fall for this time. Now acceleration is minus 2v, and it is v dv by dx, and cancelling v with v, dv will be equal to minus 2 dx, and integrating both the sides, the limit of v would be from under root of 2gh to 0, and limit of x would be from 0 to the height is, this height is 100 minus h, so 0 to 100 minus h. So it would be under root 2gh, and this is equal to minus, in fact plus 2 into 100 minus h. So squaring this equation, you can see that 2gh will be equal to 4 into 100 minus h whole square, and h would be 80 by solving this quadratic equation. Now we have to find out the time after which he should open the parachute so that he falls on the ground with zero velocity. So the time would be under root of 2h by g. So time would be under root of 2 into 80 by 10. So it is 4 seconds. So the correct answer is 4 seconds. Now we move on the next question. Now in this question, you can see that the velocity of a particle which is moving in positive x-axis varies according to the relation v is equal to alpha root x, where alpha is a positive constant. So assuming that at t is equal to 0, the particle was located at x is equal to 0, we have to find out the time dependence of velocity and acceleration of the particle, and the average velocity of the particle averaged over the time that it would take to cover first s meters of its path. I would elaborate the question B when I would solve that. Let us first of all solve the question A. So we know that v is equal to alpha root x. Now you can see that we can write v as dx by dt, and this as alpha root x, and dx upon root x is equal to alpha dt. The limit of x would be from 0 to x, and limit of t would be from 0 to t, and the integration of 1 upon root x would be 2 root x, and the limit would be from 0 to x, and here it would be alpha t. Okay, so 2 root x will be equal to alpha t, and x will be equal to alpha square t square by 4. So this is the displacement of the particle in terms of the time. Now we have to find out the velocity. So v will be equal to dx by dt. So it would be alpha square by 2 t. Okay, so this is the velocity, and acceleration A will be equal to dv by dt. So dv by dt is alpha square by 2. So acceleration is constant and it is independent of time. You can find out the acceleration with by another method, that v is equal to alpha root x. So dv by dx will be equal to alpha by 2, and this is root x in the denominator, and we know that the acceleration is equal to v dv by dx. So a would be equal to v, which is alpha root x, and dv by dx, which is alpha by 2 under root x in the denominator. So you can see that it is alpha square by 2. Okay, so these are the answers of question number 1, which is question number A. Now let us move on question number B. Question number B says that we have to find out the average velocity of the particle in the time in which it would cover first s meters. So let us find out the time in which it would cover first s meters. So you can see that it is starting from x is equal to 0, and x as a function of time is this one, where it is, yes, this one. So this is alpha square t square by 4. So x is equal to alpha square t square by 4, and we have to find out the time in which it would cover distance s. So let us suppose that at t is equal to t, x is equal to s. So s is equal to alpha square by 4 into t square. So t square will be equal to 4s by alpha square. T will be equal to 2 root s by alpha. This is the time in which it would cover first s meter. Now average velocity, v average, is equal to the total distance or total displacement travelled upon time taken. So v average would be equal to s upon 2 root s by alpha. So it would be alpha root s by 2. So this is the average velocity in that time in which it would cover s distance. Now let us move on the next question. In this question, you can see that at t is equal to 0, a particle was at origin and it moves in the positive direction of x-axis. Its velocity vary with the time like that, and v0 is a initial velocity of the particle whose magnitude was 10, and tau is the another constant, which is 5 seconds. We have to find out the x coordinate of the particle at the moment of time 6, 10 and 20, and we have to find out that moments of time when the distance of the particle is 10 centimeter from origin. So let us solve the part 1. So we know that v is equal to v0 1 minus t by 5, and v0 is also equal to 10. So this is 1 minus t by 5. Okay, so this is the velocity of the particle. Now we can write it down as dx by dt, and it is 10 into 1 minus t by 5. So dx is equal to 10 minus 2t into dt, and integrating both the sides, limit would be from 0 to x and 0 to t. So x would be equal to 10t minus t square. Okay, now at t is equal to 6 seconds, x is equal to, this is 60 and minus 36, so it would be 24. At t is equal to 10 seconds, x would be equal to 100 minus 100, that is 0. And at t is equal to 20 seconds, x will be 200 minus 400, that is minus 200. Okay, and the moments of time when the distance of this particle is 10. Now first of all, let us see that at at t is equal to 0, x was 0. Okay, you can see that. So the x coordinate of the particles at 6 seconds would be 24, at 10 seconds would be 0, and at 20 seconds it would be minus 200. So now the moments of time when the particle is at a distance of 10 centimeter from the origin. So at a distance of 10 centimeter from origin, which means that it can be 2 points A and B if it is moving only on x-axis. So it is either this is 10 or either this is 10. So x could be either plus 10 or minus 10. So let us substitute x as 10. So 10 is equal to 10t minus t square. Okay, or let us find out the value of t in terms of x, and then afterwards we'll substitute the value of x. So x is equal to 10t minus t square. So t square minus 10t plus x is 0. So t will be equal to plus 10 plus minus under root. This is 100 and minus 4x divided by 2. Okay, so let us put the value x as 10. So you can see that t would be equal to 10 plus minus under root. This is 60 by 2. So time cannot be negative, and in fact you can see that t is either 10 plus root 60 by 2, or t is either 10 minus root 60 by 2. Both are possible, and if let us substitute x as minus 10, so t would be equal to 10 plus minus under root of 140 by 2. So you can see that at this negative sign would not be possible, because in this case time would be negative, so only this is possible. So these are the 3 times at which particle is at a distance of 10 centimeter from origin. Now you can also cross check these times by putting these values in this equation. Okay, so this was the question. Now let's move on the next problem. In this question, you can see that a point moves rectilinearly with d acceleration whose magnitude depends on the velocity, like that. A is some positive constant, and at initial moment of time the velocity of this point was v0. Okay, so we have to find out that the distance it would travel before it stops, and the time taken by the particle to stop. Okay, so first of all, let us see that the retardation, which is minus v dv by dx, is equal to a root v. So you can see that root of v dv is equal to a dx integration, and limit would be from v0 to 0 and 0 to s. So the integration of this term would be v to the power 3 by 2 and into 2 by 3, and here it would be as. Okay, so this is v0. So s is equal to 2 by 3a v0 to the power 3 by 2. This is s, and we have to find out the distance and the time it would take to cover that distance. So to calculate the time, let us write down acceleration as minus dv by dt, and that would be equal to a root v. So dv by root v is equal to a dt, and limit would be from v0 to 0, from 0 to t. So integration of this term would be 2 root v0, and here it would be at. So time would be 2 root v0 and divided by a, and distance would be 2 by 3 a v0 to the power 3 by 2. Now let's move on the next question. In this question, a particle starts moving rectilinearly at t is equal to 0 in such a way such that its velocity changes with time as per this equation. So you can see that in the interval of time between 0 to 2 seconds, velocity is this, and in the interval of time from 2 to 4 second, velocity is this. So we have to find out the interval of time from 0 to 4 second in which particle is retarding, and we have to find out the maximum speed attained by the particle in this interval. So let us analyze that. First of all, in 0 to 2 seconds, v is equal to, this is t square minus 2t, and a is equal to 2t minus 2. So let us find out a dot v. So a dot v would be t square minus 2t into t minus 1 into 2. You can see that when they are a dot v is 0, then time is either 2 seconds or either 1 second. So I can say that if t is less than 2 and t is greater than 1, then this term a dot v would be negative. So a dot v would be negative because this term would be negative and this term would be positive. So a dot v would be negative. So this is a retarding motion. So the retardation period is from 1 to 2, and this is retardation. And if the time is less than 1 second, so it is also less than 2 seconds. So these both terms are negative. So a dot v would be positive. So a dot v is positive, and hence it is acceleration. So we have to find out the retardation period. Now in time 2 to 4 seconds, v is equal to, this is minus t square plus 6t minus 8. You can write down v, and you can write down v as, this is minus t square plus 4t plus 2t minus 8. So v is equal to minus t, and this is t minus 4 plus 2, and this is t minus 4. So v is equal to t minus 4 into 2 minus t. Okay, and a, acceleration of the particle, a is equal to, this is minus 2t plus 6, minus 2t plus 6, and a dot v is minus 2t plus 6 multiplied by t minus 4 multiplied by 2 minus t. So you can again write it down as 2t minus 6 into t minus 4 into t minus 2. Okay, now you can see that, let us write down the time periods, that in time between 2 to 3 seconds, you can see that this is 0 this term is 0 at 3 seconds, 4 seconds and 2 seconds. So in time 2 to 3 seconds, let's suppose this is A, this is B and this is C. So A will be negative. You can see that between this is 0 at 3 seconds, so before 3 seconds it would be negative. B is also negative, and C is positive, which means that A dot V is positive and hence it is acceleration in this period. So in T from 3 to 4, you can see that A will be positive and C would be positive and B would be negative. So this period would be retardation because A dot V is negative. So the retardation period is, initially it was 1 to 2 and then it is 3 to 4. Now for part B, you can see that for part B we have to find out the maximum speed. So maximum speed is will be when the acceleration will be 0. So you can see that in this interval the acceleration is 0 at t is equal to 1 seconds, in 0 to 2 seconds. So if we put t is equal to 1 here, then it would be 1 minus 2, which is minus 1. So in this interval the maximum speed is 1, and in this interval you can see that the acceleration is this, so it is 0 at t is equal to 3. So at t is equal to 3, if you substitute 3 here, then this is minus 9 plus 18 minus 8. So this would be plus 1. So speed again is maximum in this interval and it is 1. So maximum interval in this complete period is 1. So Vmax is 1. Now we move on the next question.